So we are going to start the discussion on the inheritance, polymorphism, and virtual functions. So this is one of the core capabilities when of the object-oriented programming. So there is a purpose of object-oriented programming. Everything you do, like consider like an object. Everything is object within the realm of object-oriented programming. So typically, why objects are important? Because you are able to encapsulate your data and functions. So data, some data is there. Data means the variables, mostly the um, instance variable for that class, and also you have some functions. So the functions are basically a way uh, to access or manipulate the data members of the class. So within the object-oriented programming, you define a class, which is the framework, basic framework, or which is the blueprint or design of the object. And then out of that class, within that class, actually, you define several functions, several instance variables, the member variables you call it, and those variables can have multiple scope of access, such as or public, private or public. Now, mostly the data members, the member, the data members of a class are private because most of the instance variables by definition of the class or by nature of the object oriented programming, by definition of the encapsulation, you do not want to uh, let external agents who are using your class or instantiating your class to manipulate those objects, because they constitute the core data structure of your object. So that's why, in order to get access or do certain manipulation within the scope of the class, you define the functions. So functions actually defines the scope of the object, what it can do, meaning its behaviors, and the instance variables or members that defines its attributes. What are the properties does an object have? The answer to those questions can be addressed through their instance variables. But their behavior, what it is capable of. Okay, what it is built of, that is the data members, what it is capable of. In order to answer that question, we design the functions. So mostly the public functions, that includes the constructor, that includes the destructor, because when you construct an object, basically it, by definition, it initializes its member functions if that is required. So you can, like we have learned, that you can have a couple different types of constructors. You can have a default constructor where you don't pass any arguments, but you can have an overloaded constructor, meaning with the same name, the constructor has the same name as the class. That is case sensitive, same name, but you can add more parameters to it. That's why we call it overloaded. So you can use a constructor to to initialize different, you can use the overloading of the constructor to define the structure, the behavior of the object differently, so that's why it is so important. If you have a calendar object, for example, if you have a calendar class, and by definition that calendar class may have the initial date set to be 01/01/1901, and end date is let's say 12/31 uh, 2200. So for 300 years that calendar is defined by definition. But as a programmer, maybe you are writing some code for some state historic sites, and where the time goes as old as I mean 1500s, I mean the on that ancient times, 1500s, 1600s, 1800s. So then typically you are going to use an overloaded constructor to customize your data definition in the class. So that is the scope of your overloaded constructor. So what I am trying to say here is that when you use an object-oriented programming framework, classes are extremely important. And then, I mean, the encapsulation, using the property of encapsulation, we can ensure two things. Number one is that you can have uh, complete object orientedness, like you encapsulate the data and the behavior separately within the class. And number two is that you ensure the security, or I mean accessibility of different attributes uh, by calling them private or public. I mean attributes or functions, whatever you call. You can have a private function, you can have a public function. Only thing is that private function does not work outside the class. I mean, you, as if you instantiate a class, you cannot use the private function of the class itself. So now we are going to a different idea. Like if you have an object, the question is, in our real life, we can have different types of functions. Of course, there is no doubt about it. We have different types of functions, but I mean, sorry, different types of objects. I'm sorry, different types of objects. But you know, there can be strongly correlated objects. Now, how you define that? I mean, one way is that you define, let's say you are coding for a bank account, you know, just you are coding for a bank account, and know, and you know what does a bank do? I mean, today the bank has a lot of things. I mean, it does a lot of things. It can manage your money by using your normal banking accounts like checking account, savings account, um, I mean, money market, whatever it is. Number two, it can also help you to invest. Number three, it can provide you with loan, home loan, let us say, car loan, home loan, whatever you want, the loans, the home equity loan, whatever you name it. And there are some banks that has a that can have some sister organizations that can provide you with some insurance needs. I mean, they can work on certain other financial instruments as well. That's not strictly bank by definition from the business perspective, but mostly bank can help you with these three aspects. Uh, now, if you want to build a software for the bank, I mean bank account, you create a bank account object. Now, this bank account object can have checking account and savings account, let us say. Now, for investment, what are you going to do? Are you going to build another object? You can do it. I mean, you can define a bank account. Even you can define an object with checking account. I mean, you have to define attributes and functions. You can do one for savings. Just a second. The volume is going down. I don't know why. Yeah. So you can have something for the savings account, and also you can, I mean, those things, and then you can create a another class for defining your investment account. But that's not really useful, because that way your I mean it will be, you have to handle, you have to keep track of a lot of objects, and it's sometimes it's difficult. So the solution is to use the inheritance. So what is inheritance, first of all? So if you think about life cycle, human life cycle, I mean, we have the parents, we have the children, and so on. I mean, and that life cycle goes on since uh, very ancient time. So inheritance is something like that. A another a class is basically, a class can inherit from a base class or parent class, or the base class can have one child class. So that kind of uh, parent-child relationship in the world of classes is roughly called inheritance. We will explore more, but that is the inheritance. And polymorphism is something little different. Polymorphism is related to inheritance, but it's not really inheritance. It's a like same thing but different form. Like for example, if you if, in the school, during the school days, we read about the polymorphism of the materials. Like carbon can have multiple that is called polymorph because it has multiple forms. It has the coal, the coal, the one we use for uh, producing the electricity, sometimes not a good way, but sometimes we use, most of the times in ancient time, we use the coals for burning coals to generate electricity. um, you should not do that. I mean, you should stop that. We should be more like green, migrate towards a green and sustainable way. But that's coal. You can have the graphite. Graphite is basically that's on your I mean, sometimes you have graphite on the pencils, the one you use to write something, not the pen, the pencils. And you can have the diamond. Diamond is also carbon. So basically, the concept is the same element, but it is showing up into different forms. Like in the object-oriented programming as well, you can tweak the functions to, I mean, you can start defining an animal, right? Animal can be an object, but this animal can be I mean, a dog can be an animal, a cat can be an animal, but ultimately they are the animal object. So how are they differentiated? The dog barks, the cat does not bark. It produces different type of sound. So by sound you can differentiate two types of animals. There are a lot other attributes as well. So basically, within the world of the classes, you can introduce some kind of behavioral attributes which is manifested through the polymorphism. We will learn more. So let's move on. We are not really right now talking about virtual functions. We'll catch it up. So, so basically, what is inheritance? As we started our discussion, it is a mean or it is a way by which you are able to create a new class from an existing class. And then the new class can is a specialized version of an existing class. Is there any example? Yes, I mean, we talked about the animal, dog, cat, but you can say you can have an you can you can define an object or a class named person. Okay, and person can have different attributes. We are not going into the different attributes yet, but then within the school you can have a student, right? So I think, I mean, the way you can understand the specialized version of existing class, person is an existing class, student can be a specialized version of the person class. So student is derived from the person class, but it can be very specialized. I mean, normal person, if you think about an average person, you can say that the date of birth, some demographic information, the name, address, date of birth, social security number. Maybe these four are the main attributes of the person. When you inherit student from the person class, the student will have all those four attributes, but on the top of that, it can acquire some other attributes as well. Like it can get a student ID, which is valid only in the school. It can have the grade. It can, I mean, GPA. It can possess a GPA. It can have the enrollment. So and so on, so on. So student can be considered a specialized version of the person object, person class. But then within the same school, you have the teachers, right? You have the teachers. Now, if you derive the teacher object from the person class, then teacher is also a person. But teachers can have other attributes as well. I mean, teachers can have, for example, they can have some different attributes such as department. uh, I mean, they have a supervisor, for example. They can have a supervisor. They can have some other things. They can have a payroll, for example. Student can have a student account. Teacher can have a payroll object. So and so on and so on. So basically, what you see here, that anything you can call to be inherited from something, if you can conceptualize and is a type of definition. For example, teacher is a person, student is a person. Whenever you find an is a type of relationship, then you talk about a an inheritance. So here, I mean, the same thing, I mean, like we already discussed. So insect is a class, is a general class. Then bumblebee is, I mean, in addition to the common insect characteristics, they have their own unique characteristics, such as the ability to sting. That's not good. Grasshopper, in addition to the common insect characteristics, grasshopper has its own unique characteristics, such as they can jump. So that is good. That's fun stuff. But being stinged is not a very fun stuff. So therefore, what we understood, that there should be an is a relationship. So, for example, a poodle is a dog, a car is a vehicle, a flower is a plant, a football player is an athlete, and so on. So basically, you are defining something. If you are defining some very high level class, you are creating some high level object, and then sometimes you don't need it to be an object. I mean, some classes may not be at all instantiated. Maybe it's inherited. I mean, the child classes are only inherited. I mean, instantiated. It may be so. So uh, so you have to have some kind of is a relationship to define inheritance. So if you think about the inherit, I mean, the terminology and notation. So you have a base class. So you can write like class student. This is your syntax for defining a class in C++. There is no, I mean, it's not a new concept. Everyone knows that. Now, what everyone does not know up to this point, I mean, we have not introduced that up to this point, is that if you want to derive a class out of the base class. So your base class, and this is the derived class. So if you derive a class out of a base class, then you have to write undergrad, let us say undergrad. Then you have to, this is the derived class. Here derived class is the undergrad. Okay, and then you put a colon. This is the syntax of C++. If you don't do that, you cannot define an inheritance. So you put a colon and then you write public students. It has to be public, otherwise you cannot use it anywhere outside its scope. So you write public and then you write student. So this notation means that undergrad is a derived class from which is derived from the student class. So in this typical scenario, student, this is the base class or parent class. You can call it parent as well. You can call it parent as well, base or parent, and then you define something else, some other class in this way. It means undergrad is the derived class or child class, and out of which class it is derived? It is derived out of the student class. So that is your syntax or notation for defining an inheritance in C++. So an object is derived, object of a derived class is a object of the base class. So your undergrad is an object of the student class. Is a undergrad is basically a student, you know, uh, a graduate student, a grad is an instance of student. I mean, not uh, the, the 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 derived from the student. So basically there is a relationship. So that is important. I mean, you define it technically in this way. It means undergrad is a student, or undergrad is derived from the student. So undergrad is the child class of the base class, which is the student class. Now, what does a child have? That's important. An object of the derived class has all members defined in the child class. I mean, you define a student inside inside this class, the second class. Here you can define a lot of variables, so they must have that. I mean, they must possess those variables. On the top of that, it 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 contains, it has access to all members declared in the parent class. An object of the derived class can use all public members defining in the child class, and all public members um, defined in the parent class. For example, if you instantiate this object, let's say if you instantiate undergrad object, this object, then it will, then that object which is a which is resulted from that instantiation, it will contain all public members of the child class as well as all public members of the parent class. So you don't have to define the public members or any member of the parent class inside the child class over again. So it will inherit those members. Just as, I mean, same thing goes for the children. They inherit certain properties from the parents, certain attributes from the parents. So they have those attributes, but then they also have their own attributes as well. So that's the way you can better define it. Now things are getting little complicated. So we are talking about the protected members and class access. So far we have talked about private and public. That's it. So what is protected? The protected member access specification is like private. I mean, if you instantiate an object, just let's say you have a person object, you instantiated that object. You cannot, I mean, the protected member after you instantiate that object is exactly like the private. You cannot accessible. You cannot access. But the main thing is that if you define a member, I mean, define an attribute to be protected, that is accessible by the objects of the derived class. The children class, a child class can have access to the protected member of the parent class or base class. So, so that, I mean, this access specification therefore now expanded. We Before that we talked about only public and private. Now we talk about private, public. Of course, private and public are there already, but on the top of that we got protected. That's a new thing. So the what is protected? Protected, any protected attribute cannot be accessed from the instance variable. I mean, sorry, from the ins, from the instance of the class or the object created out of the class. You cannot use that object to access the protected variable, but the protected variable can be accessed from the uh, inherited class or the derived class. We'll see that. So basically we ended up with three different access specification: public, private, and protected. So public is absolutely relaxed. I mean, there is no restriction to access that attribute. Protected attribute are more restrictive than public, but allows derived classes or child classes to know details of the parents. I mean, to access to I mean, child class can access the protected member variable of the parent class. And then private variables, it prevents object of derived class from being treated as objects of the base class. So um, basically, the private member variables cannot be accessed from the derived class at all. So that's what it says. So private, if your attribute is private, it is absolutely private. It does not go outside the class. But if it is protected, it goes outside the class only if the second class is a derived class. So you can see here, we we see that base class members, you have private, protected, and public. X, Y, Z, we have three attributes. So inherited base class members appear in the derived class. So X is inaccessible. You cannot access X even from the child class. I mean, in practical life, a parent can have secret. Those secret cannot be accessed by by their children. They can only have some common things, but the secret stuff they cannot access it. So that's about it. And then protected variable, if something is protected, then the base class is, I mean, it has access to that protected variable. Now, inherited base class members appear in the derived class. It looks like a private within the derived class. So basically, from outside the derived class, if you instantiate this derived class, this Y will be private to them from outside. And then public, if base class member is public, then the inherited base members appear in the derived class as private. You cannot just publish. I mean, it is not like that. I mean, your inherited class or child class is not a uh, not a door to open all the secrets of the, I mean, semi-secret or full secrets of the base class. So basically, the private members, they are never accessible from anywhere. Only protected members can be accessed by the inherited class. But if someone instantiates the inherited class, these protected variables that these like inherited classes inherit from the base class, that becomes private to the outside object. So that is not accessible outside. Now, if you have private X, protected Y, and public Z, then you have, I mean, you have if you have a protected base class, then X is inaccessible, Y is protected, Z is protected. Now, if you have private, protected, and public, now what happens? You know, public base class, if the base class is public, you can have, uh, I mean, in this base class, if you define a base class like that here, this one, it does not necessarily be a public. It can be private, it can be protected. The access modifier for the derived class. So if your derived class is private, then everything here is private. If your derived class is protected, then your everything is basically protected. And if it is public, then your, I'm sorry, I should have told it in a different way. So it should be like that. You have public here. It is the property of the base class. I mean, if it is inherited, but if the base class is private or public or protected, then we expect these behaviors. If the base class is private, then everything is private here. If base class is protected, then base class is, everything is protected. That means if it is protected, then you can also extend, I mean, you can have a child class of the derived class as well. In that case, depending on the nature of the child class, how it is derived, it can be protected or private or public. Now, if the base class is public, I mean, when you inherit, then X is inaccessible in any case, but it is protected. This Y is protected and Z is public. So it reflects the exact situation as in the public as in the base class. So these are the access modifier that is flowing through the inheritance. So this table, I mean, revise it very carefully because this has all the uh, critical information about access modification or the access specification within the base class and the inherited class. So you have a class grade, for example, if you write a class grade, so you can see that you have private members such as letter, you have score, you have calculate grade. I mean, that is those are the private member. So these are the two variables or uh, member attributes. This is a private member function. So that means if you instantiate this class, you cannot use the calculate grade function because it's private. But there are public members, set score, get score, and get letter. So you have the letter, you can get letter, you can set score and get score. So that's all you can do. So now there is a class test which is uh, which is derived from public version of the grade class, and this test class has their own set of members. You have let's say private members are number of question. Test means your test, I mean like the quiz, for example. So you have the number of questions, you have the points each question, you have number missed. Then public members is this one. Now when test class inherits from the grade class using public class access, you know what I mean by public class access in the previous, in this we are highlighting this situation here. Using the public class access, it looks like this. Its private members are um, these three public members, basically test whatever, and then you have all these functions, they go there. So we did not define these functions within this class, but since it is inherited through public class access here, the test function, test class has, as usual, they have these private members, but in addition, they have these following public members. That means these members, set score, get later, they are derived from here. So that is the essence of your inheritance. Now, if you inherit the same class using, if you have the same relationship, but you use the protected class access. So that means you did it in this way here. Then what happens, you know, your private members will be the same. Public members will be, of course, test because it is public here. So it is public here as well. But the protected members should be this one. So public members of grade class becomes protected members of the derived class. Remember that they will no longer be private, public. They will be treated as protected because you are inheriting the from. I mean, this test class is inheriting from the grade class using the protected class access. That is very important. You know, if you compare it with any other language, you won't find it. It is very special about C++. You can have absolutely customizable inheritance here. So in the third situation, that is the most restrictive situation. If you have private, I mean, if you inherit, if test inherits grade using private access modifier, then everything becomes private. Everything in the grade becomes private within the members. I mean, sorry, within the test. So once this is the test and you are inheriting grade, and then when you create the object out of test, I'm not talking about the grade, the test object, it will have these six private members, meaning these three and these three. And these are coming from here. Although they are public in the grade class, they are private in the uh, test class, because the test class is inheriting from grade class using the private access modifier. And then you have the only public members in the object that you instantiate are the test, is the test. So that is the difference between how you inherit. So if you think about Java, for example, I mean, I'm not bringing up some unrelated references. Just for example, there is another object-oriented language called Java, which is much simpler to C++. But if you think about Java, then it does not allow this customization of the inheritance. But if you see C++, I mean, it allows you to inherit in three different ways as far as the access modifier goes. So that is a very good, I mean, very beneficial hierarchy. It is a very beneficial and very comprehensive hierarchy that C++ is going to provide you. So, any question up to this point? We are we will be moving forward and we will do some coding as well, but these are the initial concepts, and it is very critical that we clarify these concepts before even start writing any code, because these concepts will form your basis of the understanding. So let's do a break for 10 minutes, and then we will come back and we will move forward. We clearly specified about the constructors and destructors, and for a single class. So the constructor basically initializes the data structure for the for the for a given class, and destructor basically it cleans up all the memories, all the memory allocations, everything, the dynamic pointers, everything is everything is destroyed during during the destructor process. And a class, if you do not define a destructor, then the C++ compiler gives you one. So a destructor does not need to be defined uh, explicitly unless you want to do some special things with that. So if you don't define, do not think that it is not called. It is the compiler gives one to the program. So now derived classes can have their own constructors and destructors. There is no doubt, because just because it is derived from some other class does not mean that it is not a class. It is a fully functioning class. It has its existence by itself, so it can have their own uh, constructors and destructors. When an object of a derived class is created, when you create an object of a derived class, the base class's constructor is executed first. So you have to understand that. I mean, a lot of questions you will see in the multiple choice, or even lot of theoretical questions in C++. They will ask you, uh, suppose you have a derived class, then you execute the constructor, then what happens? I mean, does the which one is executed first? So that sometimes is confusing, but the answer is the base class's constructor is executed first. Then the derived class's constructor is executed. So you have a base class, you have a derived class. So when you instantiate, this is the base class, this is the derived class. So there is an inheritance, and when you create an object out of it, then out of the derived class, then first the constructor of the base class or parent class is executed, and second the constructor of the derived class is executed. That is the sequence. Now, when an object of a derived class is destroyed, the destructor, now we are talking about destructor, the derived class destructor is called first, it's just opposite, and then you call the destructor of the base class. So when you create it, when you create an object, whenever we talk about constructor, its base class comes first, derived class comes second, but when it is the constructor, but when you talk about the destructor, the base class is second, first comes the derived class. So it's just opposite order. But if you think rationally, it is not really opposite order. I mean, you have to clean up the existing payload that is built up out of the derived class, because derived class can have its own payload of the memories. So you should clean up first, because if you clean up the base class's payload, then the derived class will be lost in context, but the memories will not be erased, just erased by default. It has to be done explicitly if there is any dynamic allocation of the memory. So that's why the by convention, not by convention, by design of the C++ compiler, the derived class destructor is executed first, then comes the base classes constructor, destructor. So we can start some programming effort at this point. So let's see. I mean, let me open up something. So just a second. Let me clean up my workspace a little bit. So here, uh, let's say, yeah, okay. So we are now going to basically demo a basic uh, inheritance. So we can create a function, create a class, create a program called inheritance demo.cpp. So we can create that, and then simply we can create a, I mean, as usual, we can define the input output stream in the top, and then we can start creating the base class, and we can define it in this way. You have the base class, I mean, define the constructor first, and then, I mean, this is the default constructor. Of course, we are doing the default constructor only because we are just illustrating. We are not doing anything very elaborate programming here. And then we write something up like that. Then we go and define the destructor. Even if we don't need any specific destructor in this particular code, it does not have anything, but let's define it, still define it. So we can say it is the destructor of the derived class. So this definition is now complete. This is your base class, and then we can just instantiate I mean, we can just define the derived class, and let's use the public scope of public scope of inheritance. So this is public. So if we do, I mean, doing this is more common. This is the most common thing. There are cases when you want private or um, protected, but not always. I mean, let us say if you want to write a program within your security realm you are writing some security code, or maybe you are writing some database connection code, then I can think of a use case where you can have a derived class from that when you make the base database class to be private. I mean, this is complex, so let's not talk about specific examples. But for example, if you have security code and you have login and password defined somewhere in the base class, you should not, I mean, as a part of your inheritance, you should not do the public implementation. I mean, public, you should not uh, derive this class, derive from base class using the public keyword, public access modifier. You should do that in absolutely either protected or the private modifier. That's the point. So now in your derived class, you can have your own constructor. So you can define it in this way, you know, and then you can say this is the derived class constructor simply. And then you can have the destructor as well. So you can say this is the derived class destructor. So you can move on and just add this is the derived class destructor. So that's very simple, right? I mean, there is no complication in the code, and that way we can just define. This is the complete definition of the class. Now we can move on and instantiate the class. So as a part of instantiation, we do the main first. I mean, that's usual stuff, what we are doing, the main function. So in the main function, we can do it like this one, and then we can define it. I mean, just to return zero first. That's the shell of your main function, and then you can do the body. So you can say, uh, let's say, we can say that it is, we are now define the, what is going on here. It should, yeah, that's fine. So you have, we are defining the derived class object, and then we do that derived class, and then we are couting. I mean, just writing down the output from it. Uh, that's it. I mean, that's the program. So let's save it clearly, and then we can do G++ dash O. We can say inheritance dot exe, and then we can say inheritance demo cpp. So if you do that again, there is some problem. So that means it looks like what is happening. Oh, sorry, I have messed it up a little bit. So it should be good now. So yeah, sorry. What did happen now? No, that's not right. That's not right. So if you do that, again, some problem. So what is going on here? Derived class is private within this context. So what is going on here? Derived class is here. So it is not private at all. I mean, it's public. How come it is? Oh, I think base class. So we have missed a modifier here. If you don't mention any modifier, it will be by default private. So that's what happened here. It needs to be public. So yeah, this time we are successful. So if we just again do that and then inheritance, then you can see, so what is going on here? Let's see. So we are now defining, I mean, basically we are starting it. We will now define a derived class object. So here, this one, we instantiate. When we instantiate, you see the base class constructor is first created, and then derived class constructor is created because this one is called Then you have derived class destructor is then created. You don't call those functions, but as a part of the life cycle, this destructor is called next, and then finally you call this destructor. So this is that simple. I mean, it's simple, and it's very straight and simple, and it's understandable. So that's how it is designed. Now, if you parse the arguments to base class constructor, I mean, how about parsing the arguments to the base class constructor? I mean, it allows selection between multiple base class constructors. So basically, your base class can have more than one constructors, right? I mean, it can have some uh, overloaded constructor. So just not one constructor, it can have more constructor. So then, I mean, it allows selection between multiple base class constructors, specify arguments to base class constructor. Like here, you have this is your base class. I mean, this is your base class, and this is your derived class. This one. So no, this is not base or derived. So basically specify argument to base constructor on derived constructor heading. So basically this is your derived constructor. So you are defining it in this way. We need to find out more concrete example about it. Let me try to find it out because this is not sufficient for us to understand. So let's see. So I'm just trying to find out quickly some example. I've not found any yet, but I believe there should be some. Oh, I was looking for a wrong place to find out. No luck. No, we'll talk about it later, but basically you can specify arguments to base constructor on derived constructor heading. I mean, you can do it with the inline constructor. So we have to write an example for that, and it should be done if the base class has no default constructor. So basically here, so you have the derived class constructor. So this is the derived class constructor square. For example, square is a um, in this case the class square is derived from the class rectangle, because I mean square is a special instance of rectangle, right? I mean, in rectangle you have two different sides, but in square you have still four sides. I mean, namely you have length and width, but they are same for the square. So you can see here you have, so here we have, this is the child class and this is the base class or parent class. Now now your derived class constructor, this here, the constructor can be defined in this way. You can say square, and then I mean this is for I mean you are defining it. It says that this one is the constructor of this class, this square class, and you say I mean integer side, and then you can also define the base class constructor rectangle side. What it does basically, so when you call this particular constructor, you call only with one side, right? You call, let's say you say square is, and then you do 10, let us say. This is the way typically you can instantiate it. When you do so, basically if you define it in this way, then it falls back to the rectangle constructor, and then it so that it defines the both sides of the rectangle as 10. So if it is 10, if you define it in this way, then it becomes 10 and this becomes 10. So that is what you are doing. That is how you pass argument to the base class constructor. Now, the constructor can be inherited as well in a derived class. There are some constructors that can be inherited from the base class. If you have a default constructor, that cannot be inherited. I mean, default constructor is, you know, what is, I mean, if you have a derived constructor that can be, sorry, if you have an overloaded constructor that can be inherited, but the default one cannot be inherited. If you don't, let's say you don't at all define any constructor at all, so then that can, then C++ will give you a default constructor that cannot be inherited. The copy constructors cannot be inherited, and the move constructors cannot be inherited either in a when you do the inheritance, when you do go through the constructor inheritance. So let's say you have this situation, you have a class defined, the base class, this is your base class. You have private function ival, and you have a double function, double private variable ival integer, and you have a double dval, so integer value, double value. Now your public constructors are integer my base integer I, my base double d. Now you derive this class, and so what you do here is you are basically use this, I mean, you are using some inline constructor like my derived, and then you define the parameter here, and then you just do my base I. That means it is integer, so it is pointed to this one. Now this is double, so this will be pointed to that one. So that is why you define it in this way, you know. So once you do that, so you can, I mean, that way you can inherit the constructors, and then you can also rewrite the my derived class. You can just do I mean, it's a more advanced way of writing the derived class. You can do it, first of all, you can do it in this way. This is simple, but then your base class remains the same. But you see, your derived class is absolutely simple. You say using my base colon colon my base. So that's, so using statement causes the class to inherit the base class constructor. So when you use the using keyword, so it causes the class to inherit the base class constructor. So uh, so basically you see here it is derived, but you are inheriting the my base constructors. So in that case, if you just instantiate this one with integer I, then this particular one will be called. If you instantiate my derived class with a double, then you will get this one. I mean this one called. So that's the power of using the using keyword. So you can do the base class functions. You can redefine the base class functions. So when you do that, you know, I mean, you have the base class functions. So your base class may contain, you know, this is your base class. It can contain a lot of functions, f1, f2, and so on. Your derived class, by definition, if they are public functions, by definition, f1 and f2 are inherited into the derived class. There is no doubt about it. But you have opportunity within the derived class to redefine these functions. So you can say that I'm not going to use this function at all. I want to redefine them. You have a complete, you can do that completely, provided your the signature, not the signature, the return types are same. They should remain same. If they are not remaining same, then these are different functions. We are talking about different things. We'll see that. Now, um, typically used to replace it used to replace a function in base class with a different actions in the derived class. So let's say we have an animal class, right? Animal class. Animal class has a function, public function, let us say, which calls void do sound. We have the body of the class, body of the function. Now your derived class, let us say that is dog. This is animal. This is dog. So now you can decide that uh, you will redefine this do sound function. So inside the do sound function, maybe you write something like see out. You write see out. You can say the animal is making a sound. But when you are in the uh, dog class, which is a derived class, which is derived from animal, you can again do void do sound. You can do that, but in that case, you may choose to write C out, sorry, and then you can write bark because you know dog can bark. So, so basically what we did here, we replace these do sound function in the animal class with the one in the derived class. If you instantiate the dog class, and then you call that do sound function, then you will see bark. You will not see animal is doing sound. I mean, other statement that is written in this base class. That is the essence of that. So, uh, I mean, it is not really same as overloading because overloading means you are using different numbers of arguments. I mean, the parameters list should be different. Number of argument or number of parameters should be different if you overload. So objects of the base class use the base class version of the function. Objects of the derived class use the derived class function version of function. So if we do a trial, I mean, let's try to do something here. Let's say we have, I mean, within the same example, let's say what is going on here? No, we don't want this one. We want the this screen here. So let's say we have the base class and then within the public definition we can have some function. Let's say we have a function called void um, do something. Okay, so you can say see out doing something base. So that is the base class. That's why I'm using the word base. Okay. Now in the derived class, you can also do the same thing. You can just call it here, and you can say instead of base, you can say doing something derived. Now you are calling this object, right? When you call this object, and if you do object dot, sorry, not dot. I mean, yeah, you can do that. Dot do something. You can statically call it do something. Then we would expect that you do not see this one, although it is inherited, but you will see the derived class. I mean, whatever is written in the derived class. So let's see. So if we now run it, so you can see doing something derived. That is only called right here. So it means that it is using the derived class. But now you may decide to instantiate the base class as well, because there is no restriction in instantiating the base class. So you can do uh, like base class B, let us say, and then you can do B dot do something, then you will see that base classes function is called. So if you do that, you can see um, what is going on. Do something, doing something. So where is yeah, here, doing something base is called. So what it says that if you call the base class, if you instantiate the base class, it will behave like a base class. If you instantiate derived class, it will behave like a derived class. This is especially prominent. Let's say we comment it out from the derived class. And now if we um, let me delete all these universe of couts, because that is distracting and that is killing the purpose of this particular illustration. So if we do that, and now if we simply compile it and run it, you know, so you can see everything is doing something base. So what is happening here? We are, where is this? Here. So let's say we are not calling this one at all. Let's say we are not instantiating base class, just the derived class. If we compile it and if we run it, you can see that doing something base is called. Even if you don't have defined any function here, it is inheriting the function from the base class, and then it is uh, executing that function and it is publishing that. But instead of doing that, you may decide to define uh, derived class's own function here with the same signature, exactly same signature. So this is called, this is not function overloading. This is something called function overriding. And you know, this gives you the clue to polymorphism. So you see here that there is a base class, there is a derived class. I mean, there is an inheritance taking place, but in this inheritance, you have the derived class is following the exactly same behavior as the base class. That's fine, the function. Now, as soon as you uncomment this one, okay, as soon as you uncomment this one and then you try to run the program again, it will take over the derived class's behavior. So the derived class is still related to the base class through an is a functionality. If you have other function defined here that and you don't define it there in the derived class, they should call, if you call it from the derived class, they should call the one from the base class. But here, the one you overridden, it is showing a different behavior. So basically, what we see, derived class is a same class. I mean, is a inherited class of the base class from the base class. So it is a base class. Derived class is a base class, but derived class has a different behavior. So this is what you mean by polymorphism. Your where your derived class is behaving differently, meaning behavior means function. Always remember, attribute means variables, behavior means function. Okay, so they behave differently, and this is done by modifying the function. I mean, in our terminology, we say redefining the base class function, and which is called the function overriding. And this is basically what you see when you have the situation perfect case for the polymorphism. So here, for example, they have a different exercise. It's little complex, but you know it's simple exercise. So you have a class called graded activity, then you have the protected, I mean, that's the protected member function. You have the letter, you have score, you have determined grade. So, protected member function, if you just instantiate the graded activity, they will not be accessible to the object created out of the graded activity. They won't be available to them, external object. So they will behave like private. Now, that's not the point here. Now, our main context here is we are defining a public graded activity constructor where we write letter and score. Then we define the mutator function. Then you define the accessor function, and your code looks like that. Now, you are deriving that class. I mean, you have a derived class curved activity, which is essentially a graded activity. If you do the curving, that means your grade is basically your grade is modified through that activity. So you have you have protected. Let us say you have defined two protected variables, raw score and percentage. So this is the score before you curved things, and percentage is the after you do the curving. So here what is happening, we are basically using this constructor. I mean, constructor is defined in this way, that this is the default constructor is called in that way, and you define everything to be zero. Now, mutator function, let's say we redefined the set score function. So what is happening here? You have the raw score equals s, and then meaning this one. So in addition to I mean, if you don't define it here, what it would do, it would call this one. It will set the score to be this one. But it do anything to the raw score? What will be the value of the raw score if you won't define it here? The value of the raw score will be zero, because if you don't have it here, these lines, if they don't exist here, that will be zero. But we define them in order to override the previous definitions. So therefore, we are getting like we set score, and then we set raw score to be s. So that way we set the value of this variable, and then we call the graded activity set score. Okay, so then we are doing here, raw score times percentage, that is the curved percentage. So here curved percentage is here, so you can set the curved percentage into this object. That way it will get this number. If you don't set it, then it will be zero. So then your accessor function, get percentage, get raw score, they are not I mean overridden. Only this one is overridden or modified. Okay, overridden or redefined. So basically, if you run the program, you can follow. I mean, you can write down the program from following the slide when you have time. You will see that if you instantiate the curved activity, and then you have the raw numeric score, if you put that number, you put the raw numeric score, then you get the curve percentage, enter the curve percentage for the student, whatever curve percentage it gives. Then you just set percentage, you put it like that. But set score, your set score is I mean overridden function, so you are calling it here set score. So ultimately what is going to happen is that your final score will reflect the curved score, because you um, you you have overridden this mutated function. So that's the reason, that's the main thing. When you do the mutate, when you override the function, then the function definition, if you think about the classes API, the definition of the function, they remain exactly the same, but only difference is that their behaviors are modified. So derived class, the curved activity is a graded activity, but the behavior of curved activity is different from graded activity. Why? Because we overridden this sets code function. And this is how polymorphism works. So this is an introduction to the polymorphism. So I think this is a good stopping point today because we have already discussed about a lot within the picture of inheritance. That's why on purpose I made it into like two episodes because we came all the way to 15.4. So what we have done in this class, so basically we first defined the scope of inheritance. What is inheritance? And especially always remember inheritance means is a, that is the main thing. Then we have put together some examples, and then we define the protected members and class access. So here you have to remember this picture basically. This picture is translated into this diagram, again class diagram. So if you combine this picture with these three diagrams, then it will give you complete sense of how things are working across the inheritance space. So when you derive a base class using private um, access um, for the base class, then your behave the private, protected, and public, all kind of variables become private in the derived class. But if you do it protected, it's intermediate. But then if you do it public, then it is exactly reflected as it is defined in the base class. But FYI, and for your information, this way is the most common way. But as I said, there can be some other use cases where they want to use private or protected. Protected, typically you use protected because the if you derive a member variable or member function to be protected, the derived class from the base class, I mean protect, if it is protected in the base class, the outside world, whoever instantiate the object, they don't have access that particular attribute or function. But your your derived class has an access to that function or variable. So that's why you make it protected so that you can pass it on towards in generations, like whoever inherits you. So, but if it is private, then it is completely private. It cannot go through the pathway of inheritance. So then we talked about constructors and destructors. How do we define them? And in that respect, here, this was a very good example where we basically use the base class constructor in the derived class constructor. And it's very simple because you define it in this way, but then you just call the constructor for the, you instantiate the derived class, then it will automatically through this code call um, those base classes constructor. And then finally, if you go there, the redefining of functions, that is what is within the scope of polymorphism. We will explore more in the next class. Now the session is open for any questions you might have. Well, if there is no question, just go through your discussions. I expect that you will write down, you will respond to the discussion questions, and also try to try to do some jump start on the labs. Start reviewing the labs, at least make some progress. If you have any problem, let me know, and also don't forget to join the office hour if you need any help. So that's it. I mean, that's it for today. We will talk next week again.